Hello! In this video, we'll continue working with some things you've been learning about in your math class related to place value and working in our base 10 number system. And today especially we'll be thinking about decimals, which are those parts of a number that are less than 1 and have our decimal point. So if you love sports, then you've seen decimals in statistics, and we've all used decimals when talking about distances and amounts of various things, and probably the most common example of using decimals in everyday life is when we're working with money. So a big question that we have today is, how do we name decimals? Now when I use this word name, I don't mean we should give the decimals a name like Frank or Sally. Maybe we could say, how do we read decimals, or how do we talk about decimals? So if I gave this number, I think most of us would have a good idea how to read or how to name this number. It would be 17. But if I gave you this number instead, with the decimal point, we might be a little less clear as to how would be the proper way to name this decimal or how to read this number. Some of us might think one way and some of us might think another. But when we have a good understanding of how to properly read decimals and talk about them, then it will help us have a better understanding of what decimals actually are, and it will help us as we learn about and compare and add, subtract, multiply, and divide decimals. So one important big idea that we'll learn today is that decimals are really just another way to write fractions. So fractions and decimals are very closely related, and their naming is similar to that too. And when we understand that well, it will help us as we continue learning about and working with these different kinds of numbers. But before we actually get into decimals, let's do a brief review of our base 10 number system that we use whenever we're counting. So you see on the screen a blue square that represents 1, and the important thing to remember with base 10 is that it all relates back to 1. 1 is very, very important. I like to think of this 1 as a square blue piece of paper. And I can count several pieces of paper here. I can count 1, 2, 3, 4, 5. And I could keep going if I wanted to. I could count 6, 7, 8, 9, and 10. And when I got to 10, I couldn't write the number 10 as just one digit. I would need to go to the next place value. So we represent that as being 10 sheets of paper linked together into one long, skinny piece. And maybe you've seen things like this with base 10 blocks or something like that. But the idea is that now we have one piece here that's worth 10. These are our 10 pieces. And then we have 5 pieces that are worth 1 each. And so if I ask, how many pieces of paper are there in this area all together? Well, that's not too hard. You could probably count them up. But one way to do this would be to think about, we have one piece that's worth 10, so we can do 1 times 10. And we also have 5 single pieces, so we can do 5 times 1 to represent that. Well, 1 times 10 is simply 10, and 5 times 1 is 5, and so 5 plus 10, or 10 plus 5, is 15. So we have 15 pieces of paper here, and the way we write that is with 1 in the tens column because we had one 10 piece, and a 5 in the ones column because we had 5 single pieces. So that's a little review, introduction of how our base 10 numbering system works with the different place values. Of course, when we have 10 of the long, skinny 10 pieces, we can put them together into a large, square, flat piece. So you see how the 10 skinny pieces work together and will fit and make one large, flat piece. And these would be our hundreds. So let's do a small example of how we could use this idea to understand a large number like this number, 351. Well, we know that each of these large blue flat pieces is worth 100, and so we see in the hundreds place value there is a 3. Therefore, I know that there must be 3 large flat pieces. So I'll take them out of the bank here and put them kind of on top of each other here. So we have our 300. Now next we look in the next place value, which is the tens place value. Each of those will be 10 times smaller than the hundreds. Looks like we need 5 tens. 1, 2, 3, 4, and 5. So we can see that all 5 of these long skinny pieces would add up to be only half of one of these hundreds. Well, we have our 5 tens, and last of all we look in the third place value, the only other place value represented here. In the ones column, there's just one little lonely red square. We changed the color because we'll talk about that later, but for now it's just important to remember the size is just 1, and that's 1/10 as large as each of these 10 pieces. And then again, as we did previously, we can say we have 3 of these. Each one is worth 100. We have 5 of these long skinny pieces. Each one is worth 10. And we have 1 small red piece worth 1. Well, 3 times 100 is 300. 5 times 10 is 50. And 1 times 1 is just 1. Now when we add all these together, how many pieces of paper are there altogether in this whole space? Well, 300 plus 50 plus 1 would be 351. And that's just an easier way to think about physically how many pieces of paper are in this many. And we see that each place value is represented by being 10 times greater than the place value to its right, or 10 times smaller than the place value to its left. Now the important thing to think about, if we go back here for a minute and look at the place values that we started by looking at, I'll get them visible again, the hundreds, tens, and ones, these are not the only 3 place values that we have. We could represent a larger place value by taking 10 of these large flat pieces and putting them together into a great big long piece that would be as wide as this but 10 times longer, and that would represent the next place value, which would be thousands, and those could be put into a larger square piece that would be 10,000s, and we could keep going on and on up into the millions and billions and these enormous place values, and we could keep going on forever potentially, and it would never have to end as long as every place value is 10 times greater than the one immediately to its right, or 10 times smaller than the one to its left. Now likewise, when we have very, very small numbers, for example, if we tear a piece of paper up, then we no longer have just one piece of paper, but we would have less than one, and that's where our decimals do come in. So right now, let's take a look at our red single piece of paper that we have here as a square. And what I'm going to do with this is I'm going to zoom in. So maybe you've done this, or you've heard of it, or you've seen it done, where you have a camera or a video camera that can zoom in on an object or a person, and that object or person doesn't actually change in size, but thanks to your perspective, it looks bigger or smaller. And so we've zoomed in on this red square, and it has become bigger to our perspective, but it's still worth just 1. So you see how small this red square is compared to the tens or the hundreds. You could think about this as being the same size as that red square, but now we have zoomed in on it. And you can see that once we zoom in, then we can divide this red square into even smaller pieces. So if you think about it, over here we would have our blue large squares that were worth 100 each. These are our hundreds. And then we had the long skinny blue pieces. These were worth 10 each. Now of course these are no longer to scale because this is our 1. So the 10 piece would have to be as wide as this one, but 10 times longer this way. So it would have to be very, very large. I'm just writing these over here as a reference for now. This is our 1 piece, and now you can see we have some pieces that are even smaller than 1. And that's where we use the decimal point to represent these smaller pieces as well. So let's look at this strip that's long and skinny. It has 10 pieces up the side of it. And we can see that it looks almost like the large piece that was representing 10 pieces of paper, except this time it's 10 times smaller than 1 piece of paper. You can see that 10 of these would add up to make just 1. So to represent what this looks like, we could use a fraction of 1/10, because we could count these as 1/10, and then 2/10, 3/10, 4/10, all the way up to when we get 10/10, and 10/10 would be the same as 1 whole to add up to make this big red square. Now in decimals, we just go on to the next place value, because every place value is 10 times smaller than the one that comes before it. So we could put our 1 here, and this place value is called the 10th place value. So now we have a name for the first place value to the right of the decimal point. Now likewise, this small red square is 1/10 as large as this long skinny red piece, which was 1/10 of one piece of paper. So this one is 1/10 of 1/10. And what we could say for 1/10 of 1/10 is 1/100th. So this is very small. It takes 100 of these small red squares to make just one large red square. It takes 10 of these 1/100th squares to make one 1/10th square. And how we would write that as a decimal is we would go to the next place value. Again, since it's 10 times smaller, we can go to the hundredths. We can put our 1 here, and this is the hundredths. So now you can see how the naming of decimals and how our understanding of decimals is both related to fractions and also to the bigger picture of the base 10 number system that goes infinitely larger one way and also infinitely smaller into the decimals. We could keep getting smaller and smaller pieces as we continue going on. So now let's look at a couple of examples of what this understanding means when we look at different decimals. So we have this decimal here that we'll try to represent with our blocks. So remember, this large red piece does not mean 100. Now this is representing just 1. So do we use any of these? No, because we don't have any holes. So it's not here, but it's as though there were a 0 here, 0 holes. So the next thing we would look at is the next place value. Here in the 10th place value, we see a 4. So remember that these long pieces are the 10ths. 10 of them would add together to make one whole. And we can count 1, 2, 3, 4 tenths. Now once we have our 4 tenths, we can say 4 of these pieces, each one is worth just 1/10. So altogether, these are not even one whole piece of paper, but these are 0 whole piece of paper, but 4 tenths worth. And then that's not all. We have another place value. This one here in the 100th place value is a 3. Remember, these small red squares are our hundredths. You can count to 1, 2, 3 of these. Now likewise, we can say we have 3 pieces and each one is worth, be careful when writing this, 0. We use our decimal point here, and then to write the 100th place value, we leave a 0 in the 10th place value. There are no tenths here, but there are hundredths. So each small red square is worth 1/100th. So we can multiply 3 times 1/100th and get to 3 hundredths. And then when we add together 4 tenths and 3 hundredths, that will bring us to what altogether? This decimal, which is what we started with. That's excellent. And the way we would read this would be 43 hundredths. So this is the principle for how to name decimals. Ignore the decimal point, read the number as you would read it normally, and then name it by the last place value represented. So this would be 43 hundredths. Let's look at one more example. Do we need any large square flat pieces? No, we don't, once again, because there are no holes. Now how many tenths do we need? Did you say 7? No, because when we look for tenths, then we are looking at this first place value to the right of the decimal point. So there are 0. Well, this is pretty easy so far. We don't need any of these. All we need are a few hundredths. So this hundredths place value has a 7. So we can count 1, 2, 3, 4, 5, 6, 7, and that's all that there is. And the way we would read this would be 7 hundredths. 7, the word, and then hundredths. You can see that these 7/100ths make up not even 1/10 of one whole piece of paper. So these are not very large. But that is a general overview of how we would name decimals and an understanding of how they relate to our base 10 numbering system and also to our understanding of fractions.